Alright, so the 100x Devs YouTube Bootcamp. Hi everyone. We're finally releasing a series of educational videos. The goal of this series is going to be learning high-paying technologies that lead to a job in 2024 that are not already out there on YouTube. I released a video a few months ago, and the video had a bunch of comments. The most upvoted comment here was the Docker and Kubernetes pass was interesting. Make a dedicated video for the same. That is what this and the next video is going to be. From there, the playground is open, the comment section is open. Let me know what you'd like to learn. The most upvoted comment is what we will learn. A few things that come to my mind are some advanced React, some advanced MERN stack, more DevOps concepts, Web3, AI is something that I'm learning very fascinatingly these days. Low latency trading systems. These are 6 things that come to mind. I feel this covers a broad aspects of things that lead to high paying tech jobs. Inside this, what specific technologies that can be broken down into 2 to 3 hour tutorial videos. Comment down, and the most upvoted comment is what we'll try to choose and learn through this series. The goal is at least 1 video, maybe 2 videos a week of pure educational content. And you will see hype content on the channel here and there, but mostly the channel is going to pivot at least for the next 1 month to a bunch of educational content because I have some time now and I'd rather spend that time teaching rather than creating hype videos, which I think we have enough of now. Cool. This video is going to be complete Docker Bootcamp part 1. Again, this is based on feedback, based on what the last video's most upvoted comment was. This video's comment section is open. Let me know what you would like to learn, and after this and the next video, that is what we will pick. Let's get right into it. Let's understand the complete Docker Bootcamp part 1. Why Docker? Why are we learning this specific technology? There are a few reasons. Reason number 1 is it was the most upvoted comment in this video. The Docker and Kubernetes pass was interesting. Make a dedicated tutorial on the same. That is what we're doing here. Only Docker, not Kubernetes. If you want Kubernetes, comment section is open. The other important reason for this is, 1, it makes it very easy to set up open source projects locally. In fact, at this point, I would urge you to go to 2 links, github.com/calcom/cal.com, and this other link. Both of these links I will link in the description. If you go to both of these links, at the very top of the source code, you will see a Dockerfile and a docker-compose file. Try to read through that, try to see if you're able to make sense of it, and then go through this video and the next one, part 2 of the Docker tutorial, and then try to open both of these files and see if you learned something. Throughout the series, we are heavily going to focus on open source because checkpointing your knowledge to open source code bases is very important. That's how you know you've learned something and you can actually apply it to the real world rather than building kiddie projects on your own. The other big reason for learning Docker is you can Dockerize your own applications using it, and you can also learn to deploy the applications that you have containerized on the internet using Docker. You can deploy on the internet on AWS without Docker as well, but no one really does it. Most people or most production worthy technologies / applications / companies deploy their applications via Docker. That is another thing we'll try to learn through this specific series, video 1 and video 2. Again, if you remember from the video, the 2 important things that I highlighted there was 1, Dockerizing your own full stack applications, 2, setting up an open source code base locally. There are a bunch of other things that we'll cover, but at a high level, the Docker part of this specific video covered these 2 things. These 2 things are what we'll try to understand in this specific video and the next one. What are we more specifically going to learn in part 1, which is this video? Number 1, what is containerization? What does it mean? Why did it come into the picture? The history of Docker. Why was Docker introduced? What is this company? Do they make profits or not? How do they make profits? How did they create a fire in 2013, 2014? And today, you can't really think of any open source project or otherwise to exist without Docker. How to install Docker and play with it locally. Containers versus images. The first buzzword when you're trying to get into DevOps / understanding Docker. What are containers? What are images? What are the difference between both these terms? A very important interview question as well. Creating a simple full stack application and introducing the Dockerfile. Now, if you don't know full stack, it is fine. We'll be creating a very simple MERN stack backend or like a JavaScript file basically. I'll basically tell you what each and every line means. So if you don't know the one stack, it's fine. If you don't understand backend applications, it's fine. We'll create a very simple full stack application, and we'll understand how you can create the Docker file for it, or basically how you can containerize this full stack application. The same knowledge can be applied to more complex full stack applications. But for now, for this video, we'll create a very simple full stack app and then containerize it. Containerizing the backend of that application, deploying that container / image something to this thing called DockerHub, which is very similar to GitHub, but for Docker and for images, pulling an image and deploying it on the internet. So here is where I'm introducing a few words / technologies / buzzwords. An image, deploying it on the internet. What does this mean? Basically, just how you might today push your code to GitHub and pull it from GitHub to an EC2 machine / AWS machine / GCP machine. Similarly, creating a Docker image, pushing that to not GitHub, but DockerHub, then pulling that to your AWS machine and seeing it work on the cloud there. Lastly, there will be a few flaws in this approach, the thing that we'll be doing. How do you fix those flaws will be left as assignments. Most of my videos / tutorials come with assignments. These are assignments you should solve. They're on GitHub, open source. Try to solve them, try to create a pull request. There are solutions already present out there, don't look at them. And in the next video, I'll be covering the solutions in case you weren't able to solve them. Cool. This is a high level of what we're covering today in part 1. In part 2, we'll try to cover what is caching and what are layers and how Docker caches layers and how it saves you a lot of time. What are volumes and networks, something called multi-stage builds. Understanding a new file called the Docker compose file, what it does, why it is used. Why did I say in the beginning there are 2 files in open source code bases you should look at? One, the Dockerfile, and one, the Docker-compose file. This is the thing we'll learn today. This is the thing we'll learn tomorrow. Adding a database to our backend, so a little bit more full stack we will do because this part is important to understand Docker Compose. Creating a Docker Compose for our backend and then going through open source projects, specifically the ones that I showed in the beginning of the video, and making sure we're able to understand everything there. That is what we'll cover tomorrow / in the next video, part 2. Part 1, we'll cover the things that I mentioned before this slide. Cool, let's get right into it. This is where I would urge you to not copy pen, but start taking notes or just create a mental model of what I'm talking about. Why containerization? Why Dockerization? Why was it introduced? Number 1, let's look at the meme first. The meme says, it works on my machine. And then the senior engineer says, well, then we'll just ship it on your machine. This might be something you might have faced if you currently work, which is something works on your machine, you push it to GitHub or wherever, and then some other senior engineer is like, hey, it doesn't work on my machine. And then your reply, the wrong reply is, well, it worked on my machine. The right reply here should be, okay, I'll check what's up or something else. But usually it's developers are very finicky. If something works on their machine and then someone else says, oh, it's not working, there's a bug here, the developer will just reply with, oh, well, it worked on my machine. This is a problem. And this is one of the reasons containerization is so cool. As you can see, the meme says that is how Docker was born. What does this whole meme mean? Basically means what Docker lets you do, or more specifically, not just Docker. What containerization means is everyone has different operating systems. You might have Windows, I have Mac, someone might have Linux. And the way to set up code bases here is very different. The way I install Node.js in my Mac machine is very different from how you install Node.js on your Windows machine. There might be a bunch of other auxiliary dependencies if you're trying to set up a code base locally, things like a database, things like Kafka, things like Redis. And you have to set up all these mini projects on your machine. The way to do it is very different on a Mac machine, on a Linux machine. Every operating system is different, and steps to run a local project on your machine, by which I mean an open source project or any full stack project, machine learning project, can vary based on the operating system. It is extremely hard to keep track of dependencies as the project grows. If your project did not have MongoDB and someone added MongoDB, all the developers in the team now have to install MongoDB on their machines. Every machine has a different way to install MongoDB. That's a mild inconvenience. What if there was a way to describe your project's configuration in a single file? Now, what does configuration mean here? Configuration means what database are we using? What dependencies do we need? What version of a dependency do we need? Do we need Node.js 18? Do we need Node.js 19? What version of Java do we need? What if we could write all of this in a single file? And I've been talking a lot about this file. This is what's called the Dockerfile, where you describe all the things that your specific container needs. What if that could be run in an isolated environment? I am on a Mac machine, you might be on a Windows machine. If this is my Mac machine, what if I could run my application in an isolated environment, which means this is my Mac's file system, and there's a mini computer running inside it, which cannot affect anything outside. It runs in a very isolated environment. If there is something buggy there, it does not have access to my whole machine. I can restrict how much RAM, CPU this thing can use. What if there was a way to run a project, an external project, an application in this containerized fashion? This would make the setup of open source projects a breeze. Why? Because an open source project could have 10 different dependencies. Let's say there is an open source project that has MongoDB as one of the dependencies and MySQL as well. Then you have to first install MongoDB, look at MongoDB's installation processes, install that on your host machine, do the same for MySQL, then maybe run node index.js, whatever is the way to start the project. Now let's say you're done with the project. You delete the project, but you still have MongoDB, you still have MySQL. That is bad. What if this was running in a single isolated environment, which is what is called a container? That way, you bring up the container, that brings up MongoDB, that brings up MySQL, that brings up the code base and starts everything. What if you run a single command and it destroys the container, which means it destroys MongoDB, MySQL and your Node.js code that is running? That is the reason why it makes the setup of open source projects a breeze, because you don't have to install independent dependencies. Everything comes in a single command. Where is all of this defined? This is defined in a single file called the Dockerfile. Lastly, it makes installation of auxiliary services easy. Basically, databases, MongoDB, Kafka, whatever services your full stack application uses. For example, if you look at the code base of cal.com, it uses Postgres as the database. It uses Node.js as the runtime environment. It might use a bunch of other dependencies that I'm forgetting now. Bringing all of this together to your machine and running a single command on your machine that starts a container where cal.com codebase is running. And when you're done with it, bringing down the container is the benefit of containerization. The other benefit is it runs the same on every operating system. Irrespective of whether you're on a Windows machine, a Mac machine or a Linux machine, you all have to run a single command, which is the same command. That command will create the container and run the container for you. That is the high level of why you need containerization, and Docker is one company that came into the picture to solve it. Before that, an official definition of containerization. Containerization involves building self-sufficient software packages that perform consistently regardless of the machine they run on. It's basically taking a snapshot of the machine, the file system, and letting you use and deploy it as a construct. Take a snapshot of a machine which has MongoDB, MySQL, the code base, Kafka. Take a snapshot, put it out there on the internet. Anyone can pull that snapshot and run it on their machine. That is what is containerization. What is Docker though? Docker is a company that realized this is a huge problem. They envisioned that this will become the norm and eventually everyone will start containerizing the application. So they created a standard for it. It's a very opinionated standard, which means it is one way to create containers, and it sort of became like a buzzword. Everyone today creates, like most people create like Docker containers. There are a bunch of other technologies that let you do containerization. Docker ended up becoming the most popular one. It was introduced in 2014, caught fire 2015 onwards. Today almost every open source project that I look at has a Dockerfile and makes like the lives of developers easier. Most open source projects have Docker files. Makes your life easy when you're trying to set up the project locally, makes it easy to deploy containers. So this is like the other benefit of containerization. Point 5 and point 6 are super important. One, they let you deploy projects very easily on the internet, how we'll see. And two, allows for container orchestration, which makes deployment a breeze. Now, what is container orchestration? If you remember my video here, Docker was only the first part. Infrastructure as code was the second part. Kubernetes was the third part. And Kubernetes is what lets you do container orchestration. Basically means it lets you, once you've created this mini computer / container which has all your dependencies, it lets you put them on various machines, be it an AWS machine, Google Cloud machine, an Azure machine, irrespective of what your cloud provider is, you run a single command to create the Docker image, and then you can orchestrate where to deploy, how to deploy using fancy technologies like Kubernetes. That's another big benefit that you might not immediately see until you start deploying applications using Docker. Right now, you might just be focused on like setting up projects locally. Eventually, when you either become a DevOps engineer or you have to containerize your application and deploy it, Kubernetes is what becomes super important, and Docker is the technology that lets you do it. Of course, there are a bunch of others. This is the most popular one. Cool hai? At this point, we know enough theory. Install Docker on your local machine. The instructions are right here. I have already run it, but if I had to run it again, I would basically go to whatever is the URL here, or just Google Docker installation. And then here there will be operating system specific steps. Let's see one for Mac OS. I think on Mac it's as simple as brew install. There you go. Select your operating system here. For example, if you're on Ubuntu, select this and run a bunch of commands. Once you do, by the end of it, this is the command that you should run, maybe without sudo. So docker run hello world. Oh, oopsie daisy. Connection timed out. Make sure your streaming service. Okay. The streaming. So docker run hello world. This will run like a very small container on your machine, and it's like a test container, which is how you know whether or not Docker is running on your machine locally. Right now, as you can see, I ran docker run hello world and it says cannot connect to the Docker daemon at some specific socket address. The reason is I don't have Docker running locally. I did install it. I don't have it running locally, which is what I'm going to do next. The way to do that on Mac, I installed it using the Docker GUI. I just had to like open the GUI, and now if I run docker run hello world, as you can see, it says unable to find image hello world locally. Then it says pulling the image from library, runs a bunch of things, and finally the important thing to see here is hello from Docker. As long as you see hello from Docker after you run docker run hello world, you're good to go. If you see some other error, that means there is an installation error. Fix that first and only then proceed in the video, else you won't be able to follow along what's happening, and then there's no point. You're stuck in tutorial hell. That is something we don't want. So make sure you're able to run docker run hello world. If you're able to run docker run hello world, which means you have Docker installed locally, in case even if it is sudo docker run hello world, that's fine as well. This means Docker needs some extra permissions to run locally, which is fine for this tutorial. Eventually, at some point, you shouldn't use sudo. You should simply give it the right permissions so it can run without sudo. Sudo basically stands for super user do, which means Docker needs some extra permissions to run locally. But even if this is the case, it's fine. Whatever commands I'm going to tell you to run from now on, just add a sudo before it. But preferably try to make sure one Docker as a command exists here. So Docker CLI gives you a bunch of things, but more importantly, docker run hello world runs on your machine. When it runs, hello from Docker is what you see. Cool. After you have done the installation, we'll understand what is exactly inside Docker. There are a few important parts which we're going to focus on. The three important parts that are inside Docker are: number one, the CLI, which stands for the command line interface, which is the thing that you just saw. When I ran the Docker command in my terminal, that is what's called the CLI. It stands for command line interface, and the name itself says interface, which means this is one way for you to run Docker commands. You can run it through code as well, through a bunch of other clients. CLI is the sort of popular way to run Docker commands. What does a Docker command run? When it runs, what thing does it hit? That's the engine. And finally, something called the registry, or like DockerHub, or a bunch of other registries where you can deploy your Docker containers, more specifically your Docker images. Too much information. Let's take a pause and let's just focus on the first one, CLI. What is a CLI? This Docker right here. This is what's called a command line interface. Ignore the PS over here, just Docker. This is what's called the command line interface. If you look at my machine here, if I run Docker, it gives me a bunch of sub commands that I can run. It says you can run Docker run, Docker exec, Docker ps, Docker build. So these are the commands that I can run. If I run Docker ps, it gives me a bunch of things which you don't have to worry about just yet. That is one of many commands that the Docker CLI lets you run. Let's move to the second part now, the engine. The engine is the main part of your Docker basically. The Docker code base, if you look at it on GitHub, the thing that actually runs mini containers, mini machines, the thing that lets you actually create images, it's what's called the Docker daemon / the Docker engine. The CLI that you have is just a way for you to interact with the Docker daemon. You could also write some Golang code that lets you run these Docker commands, for example, Docker PS, Docker image, Docker build. You can also use the CLI to interact with it, but both of these finally talk to the Docker daemon. This is the thing that is running, which does the management of your images, lets you create images, lets you create containers, volumes, networks, a bunch of other things. Probably the most important part of Docker, the meat of where the Docker code base runs, is the Docker daemon or the Docker engine. Lastly, the way that Docker makes money is through something called DockerHub. There are a bunch of other ways, but the most important part is DockerHub. It's basically their alternate to GitHub. What does GitHub let you do? GitHub lets you put your source code into a centralized place on the web where people can pull your source code from there. DockerHub is very similar, only when you're deploying onto DockerHub, you're not deploying code, you're actually deploying an image. What are you deploying? An image. What is an image? We will see very soon. But there is a very big difference between GitHub and DockerHub. If I go to whatever github.com/hkirat/docker roadmap, this has the source code, which means it has a bunch of JavaScript files, TypeScript files, HTML files. If I go to DockerHub and let's say look at an image, this does not have the source code. Well, it does have the source code of MongoDB. It has a bunch of extra things there. It has like the file system needed, it has the networking setup, a bunch of other things. We will see very soon how you can create these images. But what you need to know at this point is, okay, DockerHub is one of many ways how Docker makes money. And what does DockerHub let an end developer do? Once a developer has created an image on their machine, they can deploy it to DockerHub. And then EC2 machines, AWS machines, GCP machines can pull your image from DockerHub onto the AWS machine and run it immediately. Very similar to GitHub. And the only thing to sort of keep in mind here is, or a few gotchas to know is, DockerHub isn't the only registry that's out there. There are a bunch of others. AWS has its own registry, GCP has its own registry. DockerHub is the most popular one because it is created by the creators of Docker. But there's this more general concept that you should know of, which is called a registry, which is this thing right here. A registry is a place where you can deploy an image. DockerHub is one of the registries. AWS has its own registry. GCP has its own registry where you can deploy Docker images. DockerHub is the most popular one. And what does a registry let you do? If this is the registry and this is your machine, you create an image locally and then you deploy that image to the registry. Everyone all around the world can look at that image. For example, I can look at the Mongo image here, and in case they want to pull that image locally and run it, they can run a bunch of Docker commands and run it locally. Cool. These are the three important concepts to know, like the high level concepts of what Docker provides you. Now let's get to images versus containers. Another big checkpoint here. We understand abhi tak ke what is Docker, what is containerization, and three high level things that Docker provides you: the CLI, the Docker engine, and DockerHub. Now we have to understand two mild concepts: images versus containers, and a very popular interview question as well. After we understand this is when we'll write a bunch of code and start to create images locally, deploying them to DockerHub, all that jazz. Cool. Let's look at the official documentation of what is an image and what is a container. A Docker image behaves like a template from which consistent containers can be created. If Docker was a traditional virtual machine, the image could be like the ISO file used to install your VM. I'll take a pause here. First important thing, the Docker image behaves like a template which is a consistent, from which consistent containers can be created. What does consistent mean? It means irrespective of whether you're running it on Windows, Ubuntu or a Mac, all three machines will see the same outcome. Similar to if you run the Docker run hello world command here, what I see is what you might see is what someone else on a different OS might see, because the image that is created is consistent, from which consistent containers can be created. If the Docker was a traditional VM, image would be like the ISO file. Now, I don't know if you've tried to install Ubuntu on your machine ever. If you have, your friend might have given you a .iso file in like a pen drive. That is one way to install virtual machines on your operating system, more specifically like what's called the the thing that's below the operating system. But VMs differ from Docker. Docker is like significantly different from virtual machines, and both in the concept and in implementation, but it's a good way to understand what are images and how they differ from containers. What are images? The ISO file your friend gives you in a pen drive if you're trying to ever install Ubuntu on your machine. What is a container? Container is when you run that image locally and that's actually executing on your machine. That's what's called a container. That's the high level difference between images and containers. We will dive a little bit deeper very soon. But until this point, what is an image? An image behaves like a template from which a consistent container can be created. Images define the initial file system state of a new container, which means the image, if you look at it, it will contain the file system, the code base, the network information, a bunch of other things. It's significantly different from just the code base. This is what you use to push to GitHub. This is what an image contains. They bundle your application, source code and its dependencies into a self-contained package that's ready to use within the container runtime. Within the image file system, content is represented as multiple independent layers. Feel free to ignore this last line. This is a high level of what are images and containers. Feel free to take a pause here and try to just read through this, try to marinate it. In the next 5 to 6 slides, we'll try to understand images and containers in more depth. Cool. Images versus containers. Let's take a more practical example. If this is your local machine, a Mac or a Ubuntu machine or a Windows machine, you might have an index.js file or a python.py file or an index.html file, whatever file. If you've ever run code base on your machine before, the command that you run is something like node index.js. You may or may not have run this. This is one way to run applications, but what are we learning today? We're learning about containerization and Dockerization. So what is the way to create a container from it? Step 1 is just creating an image. The docker build command lets you take this index.js file and describe, okay, what all do I need along with the index.js file, and create an image from it. What is an image? It contains your index.js file. It also contains ki haan, this is an image which should have node.js in it. This is an image which should have a file system in it. This is an image that should expose a certain port maybe. If you don't understand the last line here, feel free to ignore. But this image is significantly different from just a file. A file is like much easier to run locally. An image is slightly harder to create because it's an independent entity which has not just your source code, but also all the dependencies your source code needs to run. Why is this useful? If you remember from the initial part of the video, I said the whole point of containerization and Dockerization is that you create some self-centric container, and this container is what you can send to your friend who's running a Windows machine, and they'll be able to run the code base. You can send it to a friend who's running a Linux machine, and they'll be able to run the code base. This is a self-contained system which has not just your code base, it also has a bunch of basically all the dependencies that your code base needs to run. Versus container is when you actually run an image locally, similar to when your friend gives you an ISO file in a pen drive. When you run it locally and you see Ubuntu running is when you can call it sort of a container. And like the high level difference is you only create an image once because, well, there's no point creating the same image twice. It's like having two index.js files that look the same. But a container you might run more than once. You might ask, Sarkirat, why would I want to run the same index.js file twice for auto scaling. Maybe there's a lot of load on your machine, so you want to run two different containers that your end users can hit, and that is when you run like docker run twice, and that gives you what? Two containers. So what is the difference between images and containers? Image is a thing you create once, which has the information in like a 1 GB file that you have, like a 2 GB file that you have, which has your file system, your mini operating system kind of a thing, networks, code base, a bunch of other things. When you run that specific image using the docker run command is what's called a container. That's an image in execution is what's called a container. This image is what you send to DockerHub. When I showed you DockerHub, the MongoDB image recently, the image is what the developer of MongoDB image pushed to DockerHub, similar to how you push your source code to GitHub. You don't push the containers onto DockerHub, similar to how you don't like run node index.js on GitHub. GitHub is meant to store your code base. DockerHub is meant to store your images. Once your image is there, you pull that image to, let's say, an AWS instance, or you give it to a friend. You point your friend to this specific MongoDB image, and you tell him, bro, you can run this locally, and that contains my source code, and everything else you need to run it locally. That's the benefit of DockerHub, and that the image is what gets stored there. When your friend pulls it locally and runs it, let's say they pull that specific image, and then they run docker run image ID, is when they will see these two containers. If they run it twice, they will see it twice. If they run it thrice, they'll see it thrice. Let me just run one of these so we have like a practical example here. This is the MongoDB Docker image. I can run docker pull Mongo, which will pull the latest Docker image for Mongo. And once it does, it will take some time, not too much. I can simply run docker and Mongo. I should give it a bunch of other arguments. But just running these two commands, docker pull Mongo followed by docker run Mongo, will one, pull the image to my machine, two, run the image, which means this is what's the container. These logs come from a container, and this is the image that was just pulled from DockerHub. Good checkpoint here. We understand, hopefully. All right, so at this point, I would urge you to read through this again. The difference between images and containers. High level, image is what you create once from your code base, which contains your code base, your file system, your networking information, a bunch of other things, a very big 1 GB file. A container is when you run that image locally, when you actually see the logs, when the service is actually running locally. If it's a website, you can actually hit that website and get some content back. That is what's a container. That's how it's different from an image. Cool. Let's proceed to coding. I think we've talked a lot now, too many abstract things, so let's try to code. At this point, I would urge you to go to github.com/hkirat/devops, Docker roadmap. This will have a bunch of files. Just focus on, just download it first or clone it, whatever. Click on download zip here. This should bring the code base locally on your machine. In case it does not bring the code base, if you want to go down the other route, you can use a bunch of git commands to run this locally. I'm not going to cover that. Fairly straightforward stuff if you've already interacted with GitHub in the past. Once you have this locally, I'd urge you to open just one -simple app. It has a bunch of things here. We'll try to read through it and understand what it says, okay? I'm going to go to part 1/one simple app locally. Would urge you to clone the repo and reach here as well. And here I'm going to basically take you through the structure of what this project looks like and what these files do before we sort of proceed into creating the Docker file. Ignoring this Docker file here, other than that, you'll see 4 files here or 5. README, feel free to ignore. The index.html file, which is a basic HTML file. It says hello world in the title, hello from a website in the body, and I want to be exposed via a container. It's like a very basic website. If I open it in Chrome, it looks something like this. Cool. The important file is the index.js file, which is a very basic Express HTTP server. Now, if you don't know what Express is, I'll give a very high-level briefing of it. If you already know it, feel free to skip through this part. Express is one of many HTTP servers. What is an HTTP server, Hakirat? It's basically a way for people to expose information on the internet. That's very abstract, so let me maybe take a moment to explain this. there are a bunch of machines out on the world. When you go to like https://google.com, what's happening under the hood is there is a request that goes out to a server somewhere in the US, a Google server, and then that returns back some HTML to you. And that is how you see HTML content in your local machine. If I open google.com here, you can actually sort of confirm this. If you right click, click on inspect, click on the network tab here, it will show you all the HTTP requests that are going out. The important one to focus on is this first google.com request that goes out. As you can see, I mean, you can, if you don't understand this part, feel free to ignore it. At a high level, whenever you go to any website here, there is a request that goes through the wires here onto a machine in the US, in the UK, in India, wherever, and some response comes back from it. The very first request that goes out gives you back some HTML. So if you go to the response here, you'll see a bunch of HTML here. This is what we're trying to emulate locally, which means we're trying to create an HTTP server that can return back some HTML. Now you might ask, Harkiyat, why do we need to do this when I can simply just open the HTML file here? And the answer is, when you open the HTML file here, this is what you see in the URL bar. And when you ever sort of expose things on the internet, whenever you go to a website, it never starts with /user/kirat or like it never starts with file :/ basically. It starts with HTTP or HTTPS, something like this. And that's how we want to deploy our application. In case we have to do that, we have to create an HTTP server. There are a bunch of ways of creating HTTP servers. Express is sort of the popular framework in JavaScript/Node.js that lets you do it. And we've created a very simple Express server here. The important thing to note here, or like the important part here, is just this bit. It says whenever a request comes on / send back the index.html file. A bunch of other boilerplate code here, which if you really want to know what this does, there is a not a Web3 roadmap, Harkiyat Singh full stack roadmap, which is this video right here basically explains it very well. So feel free to go here and look at what Express is, how it lets you create HTTP servers. I'm not going to explain that. The important thing here is when I start this HTTP server, which means if I run node index.js, which basically means if you want to run this locally, you need to have node running locally on your machine. This is the reason we're introducing Docker here, because if you want to run this locally without Docker, then this is the command you need to run. And for that, you need to have node installed in your machine locally. Steps are fairly straightforward if you want to try it. You don't have to try it because eventually we're going to use Docker to run it. All you need in your machine is Docker. Everything else is sort of automated. Cool. If I run in node index.js, it says cannot find module express because the first command I need to run before that is npm install. When I run npm install and then I run npm node index.js is when it says an app is running on port 3000. Again, if you want to understand all of this very well, then just go through the roadmap, the full stack roadmap. But now if I go to localhost :3000, as you can see, I can basically start it from http://. This looks very similar to a Google website. There are some differences here. It says your connection is not secure. Here it says it is secure. You don't have to worry about that just yet. The thing is, we have created an HTTP server. The problem is the HTTP server requires you or anyone else, if this was an open source project, they would need to have Node installed locally, which is bad. This is why we need to containerize this application, because if we containerize it, if we create Docker files for it, other people don't need Node in their machine. They can simply use Docker to run the whole thing, this whole project, this Hello World website locally. And that is the way to do that is through what's called a Dockerfile. Let me just take you through the other files here. Index.html we saw, index.js we saw. Package.json is like the only other important file here. You can ignore package-log.json. Package.json is basically a place where you write a bunch of things for your Node.js application. The most important part maybe here might be this dependencies section, which here it says Express is a dependency. What is Express? As I've said, it's an HTTP server. If you want to dive more, I cover all of this in the full stack roadmap that's on YouTube already. All right. Cool. Checkpoint. We coded a little bit. I took you through the code base of what we'll be deploying today or what we'll be containerizing. It's a simple Express application that exposes some HTML code on the slash route on a specific port, more specifically the 3000 port. The thing that we need to do from here is containerize this application, create the Docker image for it, run the container locally, and visit the website in a containerized fashion, not run it on my machine like I was running it right now, running it inside a container. How do you do that? And the answer is, this is our application. The way to containerize it is by creating what's called a Dockerfile. All right, so the Dockerfile, the most important slide maybe of this specific video. This is where you spend a lot of your time if you're a DevOps engineer. This is where you describe to run your full stack application, what dependencies do you need, what external libraries do you need, what all ports do you need to expose, what final command that you need to run to convert your image into an actual running container. Where can you find your JavaScript files? All of this is described in a single very long file called the Dockerfile. And where does this reside? This resides right next to your source code. This is my source code for my application, the index.js file, the package.json file. Right next to it is the Docker file, which contains all of this configuration. For this specific project, this is what the configuration looks like. Let's go over all the things from top to bottom. The very first thing says from node 20. So the first line usually of any Docker file is going to be from space something. The something on the right is what's called the base image. Base image represents, okay, you are creating a very big image from here onwards. What is the base image that you should start from? Usually this is something like Ubuntu, like a very basic Ubuntu operating system image, which has everything that Ubuntu does. So if you install Ubuntu from a friend, the thing that you get there, the same thing you get if you at the very top write from Ubuntu and a version of it. But since we know, okay, this specific application is a Node.js application, why not use a node base image that some very smart people have already created over there? If I go to DockerHub, I can actually just search for DockerHub image Node.js, and this will give me the node official image, which basically is an operating system, a bunch of extra dependencies that have node, npm, nvm, all the right set of libraries needed for you to run a Node.js application. Similar images exist for Golang. For example, this is the Golang base image. If you don't want to do all of this, you can always be like, bro, I am just going to use the Ubuntu base image, or there's a Scratch base image, which is basically like literally nothing from scratch, or they're like more lightweight versions of operating systems. The famous one is called Alpine. You can write that, and right below this from step is where you can write the installation steps for Node. On your machine, if the first time you install Node and npm, you somehow install nvm, which is like the Node version manager on your machine. Then you do an nvm install Node or whatever. You can write all these steps here in the Docker file. You can bring in nvm, do an nvm install Node. If you want the base image to be Ubuntu or Alpine, if you don't want to be this fancy, but generally if you have a Node.js application, you will use like the Node base image and just write the specific version of Node that you need. This has been written by really smart people who have like deployed the official Node image there. What does it have? It has the file system and all the dependencies needed for Node to run on that file system. The next step here is what's called the work dir or the working directory. This represents where exactly do you want to work when you run a bunch of commands after this. This is basically the base directory inside the image where you want to pull your code, run the commands, all that jazz. So if you look at my file system right now, I am in what folder? I am in /users/keyret/project/100xdev/devops series/part1/one simple app. This is the folder that I am in. Similarly, what are you containing? You're creating like a mini computer, right? You basically tell कि हाँ, in the mini computer, this is where I want, this is my working directory, this is where I want to pull my code base, run my code base from, all that jazz. When you put a working directory and then you run something like, for example, copy dot, which basically means copy everything from this folder into the Docker file or like the Docker image, this working directory is where that code will go. So these two lines, if you combine them, what do? they change the folder inside the Docker image to this base folder, and secondly, they copy over everything from this folder, which means the Docker file, the index.html file, the package.json, the index.js. All of this gets copied over where? Inside your image. If this is your final image that is being created, in the /user/source/app folder is where we copy over all the source code and put it where? Inside the image. We will later be able to like SSH into one of these containers that are running this image, and we'll actually see that the /user/source/app folder actually contains all of this code. But for now, feel free to ignore. The high level thing to know is this copy command will copy over all your code base into this working directory. And why are we doing this? Because we are creating the image. This is the file that represents the configuration of your final Docker image. So you need to put all of your code there because your code is what finally runs. Cool. Moving on. The next command to run here is npm install. Now this is slightly debatable. Some people say, okay, you should run npm install here. What does npm install do? For the people who don't know, it creates this folder called node modules, which contains all of your external dependencies. What are external dependencies? Anything that's mentioned here in package.json in the dependencies section, which is in our case is express, is what you bring from a very like open registry onto your machine, and running that single command creates node modules. Now some people argue, okay, bhai, you should run npm install here, and then after you have run npm install is when you should create your image. So when you run copy, node modules will move to your working directory automatically. So you don't really need this step. But ideally, you want to create a fresh image, which means you don't want to copy over node modules into your image. You want to copy over just the source code that's written by hand, and inside the image is where you want to run npm install and bring node modules there. Why? There are a few reasons. The biggest reason is when I'm sort of bringing in node modules here, I might bring in, let's say, a few C++ or C files, which then get built on my Mac, and then the way they're built on my Mac might not be the way they need to be built on a Linux machine, which is what we're sort of working with here if we're using like the base version node, whatever, 20. So whenever npm install happens, basically there are a bunch of OS specific things that happen, and since we know we're running maybe Linux or Ubuntu or whatever, and that is written here in the Docker file, why not run npm install directly inside the image in that specific environment rather than running it on my Mac and then copying over node modules? So interview question, should you copy over node modules from your file system over to the Docker image? The answer is no. You should just copy over the source code. You should copy over package.json, and inside the image is where you should run npm install. Cool. One way to sort of ensure that you never copy over node modules into your Docker images, create a .dockerignore file, which I already have, and inside this put like node modules. Whatever you have inside the .dockerignore file won't be copied over whenever the copy command runs. So if you have something in .dockerignore, it won't get copied over whenever the copy command runs and something is being copied. Again, what does dot mean here? Dot means everything. If I wrote something like copy dot slash index.js dot, it would mean just copy the index.js file here. So I could also write something like copy dot slash index.js and package.json over to the image. So the thing on the right represents inside this working directory, where do you want to put the files? The thing on the left represents what files you need to copy over there. Again, in our case, we're just going to do copy dot dot, which means in this working directory, put all of the code that's present here. That includes everything, including the Docker file, which is something you don't really need inside the image, but it's fine. You can also put like the Docker file in dockerignore. I think that will be fine as well. Let me just do that real quick. Cool. So that is step number 4. Step number 5 is exposing a specific port. Now this is something new. As you saw when I was starting the index.js file, I saw an HTTP server was created on port 3000, And whenever in my browser I went to localhost colon 3000, I saw the website. The thing is, containers are not always HTTP servers. Containers could just run some very heavy algorithm and then die down. They don't necessarily have to be long running HTTP servers, which means they don't necessarily have to expose anything. Whenever these fancy technologies like containers are created, whenever these containers are created, you don't want to give them too much power, which means if this container says I am running something on localhost colon 3000, the machine shouldn't really send all the requests coming on port 3000 to the container. The container should expose that port, and then the machine can decide whether or not to actually send requests there. But the container's job at the very minimum is to tell ki haan, this is a port that I am exposing. So if there is an incoming request that's coming my way, please send it to me. The Mac machine, the host machine that's running the container can decide whether or not to forward the request there. And that's what we're doing right here. Ki haan, the container is exposing port 3000. If the index.js file had a different port here rather than 3000, that is what we would expose in the Dockerfile. Cool. Let's go from top to bottom. Base image working directory, copy over the source code, run npm install to add node modules and expose port 3000. Last command is cmd, basically represents what command to run when the container is running. Big difference between all of these and this single command. All of these run when you are creating the image, the 1 GB file. This runs when you are running the image, which means when you are starting the container. This does not run when you are creating the image. This only runs when you actually start the image and create the container. That is again interview question. The question usually is what's the difference between CMD and run? The answer is you can have multiple runs. A run basically means install a bunch of things, bring a bunch of things on the machine. If you were installing, let's say, Golang as a dependency, you would use run and like bring Golang onto this machine. CMD means before the image gets converted to a container, which means you actually start the container, run this. Cool. This is the general structure of most Docker files that you'll see. They're much bigger. There are a bunch of other things that we'll discuss in the second part. But at a high level, this is a basic one for Node.js. A Golang one would look very similar. It might have an extra step of compilation, but other than that, it look pretty similar. Alrighty. So hopefully we understand what a Docker file looks like and at least understand the Docker file for our basic full stack application. Next question is, how can you create an image from this Docker file? How can you run the image from the Docker file? Fairly simple commands. This is how you build an image. So let's run that command. It says docker build dot, which means the folder in which the Docker file and the source code is, -t, a tag name. It's like an image, an ID, not an image, an ID that you can give to that specific image. So let me give it an ID of what, not exactly an ID, it's basically called a tag. Let's tag it with test app. And that's it. This single command will create your image, which means it will bring the Node.js base image locally to my machine, the Node.js 20 image. It will copy over my source code, run npm install, expose the 3000 port and create a very nice image for me locally. As you can see, it takes some time because, well, step 1 of 4, which is bringing from docker.io/library/node at 20, it's taking some time, rightfully so. It's a big image that's coming from DockerHub to my machine. Let's wait for it to finish. As you can see, it still says 1/4. And if you don't know what 1 here is, or 1/4 here is, 1 is this step. This is 1/4, this is 2/4, this is 3/4, this is 4/4. These are the like 4 high-level steps to create this image. This one isn't really a step, it's exposing the port, and this one again, as I said, does not run when you're creating the image. This only runs when you're running the image. Took almost a minute. Still fetching the image from DockerHub. 2/4 work dir. 3/4 copy over the source code. 4/4 run npm install. By the end of it, our image has been created. Took almost a minute. Let's run. All right, let's run Docker images, and as you can see, amongst the many images that I already have, I also have the test app image now, which was created 2 minutes ago, and its size is 1.1 GB. This is the image that we just created. And the next popular command that you might have been waiting for is how can I convert this image into a container, which means how can I actually run this image? And the answer is, let's see, what was the tag of the image? It was test_app. The way to run it is docker run test_app. That's literally it. This command will start that image, which means it will start a container from that image. And as you can see, it does say example app running on port 3000, which means if I go to my browser, if I go to localhost :3000, will I see anything? I should have, but I don't see anything. Why? Small caveat to discuss. Whenever you're running images, right, as I said, if this is your Mac machine doesn't really want any random container to start, and any request that's coming to localhost :3000, which means any request that's coming to the Mac machine on port 3000 to get routed automatically to a container. A container might be like, bro, I'm exposing something on 3000. There might be another container that says, bro, I'm exposing something on 3000. It depends on the Mac machine. Okay, where does it want a request that's coming on 3000 on Mac to get routed, container 1 or container 2? How do you describe that? The way to describe that is by using an argument here. So let me stop this. The argument is -p, which means the port, more specifically the port mapping. What have I mapped here? I've said docker run test app, but -p 3000:3000, which means the 3000 port of the Mac machine should forward all requests to the 3000 port of the container that this specific command is starting. So now if I run this, and if I go to localhost :3000, I see hello from a website. What is the new thing that I added? I simply added another argument here, -p. I said 3000 from my machine, from the Mac machine, should point to 3000 on the container. And if you change this to, let's say 3001 or 3003, now if I go to 3000, this won't work. But if I go to 3003, it does work, because I've said this is my host machine port, this is my container port. Any request that's coming on the host machine on 3003, route it to the container on 3000. Okay? That's how you start an image. How do I know that the image has started and a container is running? If I run docker ps in a different terminal, it shows me this is the container ID that's running. The image that it's running is test app. This is the command that ran it, and it was created this much time ago, this time that it's been up, all that jazz. If I stop this, I don't see anything when I run docker ps. That's the brief of the difference between docker build, which lets you create an image, docker run, that lets you create a container. Do we now understand the difference between images and containers? Docker images still has a bunch of my images. Usually this keeps on getting cluttered because you keep creating images as time goes by, pushing them to DockerHub, all that jazz, pulling them from DockerHub. But you don't usually have a bunch of them running locally. The project that you're working on locally is what you have running locally. Whenever you move from that project to a different one, you start a different container. So you'll usually have a bunch of images on your machines. All of these are like 1 GB, 2 GB, 700 MB. But whenever you actually want an app to run on your machine is when you run docker run whatever. Only thing is there are a bunch of arguments that you can put here. We'll just put one right now, -p, which as you saw lets you do a port mapping. There are a bunch of other arguments that we'll see later on. Cool. Let's move on and let's see how you can push your code to DockerHub. This is the part that you might have been waiting for. This is like the fancy bit where we now have an image locally, but I want to push it to DockerHub to, one, put it out there for everyone to see, to be able to let my friends try my code base out. The way to do that is fairly straightforward. Let's first look at the high level flow of how this happens. After you've created the image locally, you can sign up on DockerHub, and very similar to how we saw the Mongo image there, you can take your, again, not the image, not the container, but the image, and you can push it onto DockerHub. Once you've pushed your image to DockerHub, your friends can pull it to their machine. You can pull it to like an AWS instance, a GCP instance. As long as the AWS instance is running Docker, or let's say you have a GCP instance which is also running Docker, you can simply run a single command here, which we will see very soon, that will pull the image from DockerHub and run it on this GCP instance. Again, this happens, this is true if you push it to like a public repository. You can create private repositories here, which is like a whole different thing. Happy to discuss later on. You don't really need it for a really long time because private, well, that's how things are actually deployed in the real world. Like you have private registries where you push your images, but it's like a very simple way to sort of move from a public to a private repository. Cool. This is the high level of how you push images and pull them on an AWS machine and run them. Let's try to actually practically do it. So step one is going to be creating an account on DockerHub. I already have one, but I would urge you to go to dockerhub.com and sign up /sign in. Once you do, you will see an interface like this. This is very similar to GitHub's interface where you can create a repository. I'm going to create a repository. Let's call it test during video. And it's created like an empty repository, similar to an empty repository in GitHub. The important thing you need to do is you need to push code here. The way to do that is, first when you're building your image, maybe tag it with the name of the repository, which in my case is 100x devs /test during video. Test during video was the name of my repository, but whenever you're on DockerHub, you have to prefix your repository is basically not just the name that you gave it, it's your username / the name that you gave it. That's what I put here. And if I press enter, I basically rebuild the same thing. Now you'll see this happens like much faster than the first time because we already have like the Node.js image locally, so it's not really re-pulling it. We'll cover a bunch of these things in the advanced section when we cover layers. But as you saw, the first time it took 60 seconds, this time it took much lesser. Now if I check my images, I have a bunch of them, but at the very top I have 100x devs /test during video, and I can simply do docker push 100x devs test during video, and it will push my image from my local machine to DockerHub. Let's wait for some time. There we go. Now if I go here and refresh, it says there is one version here with the latest tag that was created a few seconds ago. And also go to like the public view, and this is something I can share with my friends and tell them, hey, I've pushed my image here, feel free to pull it and run it locally, which means all they have to do is run a single command, docker pull followed by docker run, and they'll be able to run everything on their machine without having Node.js installed on their machine. They just need Docker and a single command, docker pull followed by docker run. They'll be able to run all of my code base in their machine. They didn't have to install any, it could be like a fresh machine which has just Docker in it. Let's try that on an AWS machine of mine. So I'm going to copy this and I'm going to SSH into an AWS machine of mine. If you don't understand this part, it's basically me logging into my AWS machine. As you can see, it's like a pretty empty AWS machine. It just has like a Docker bot running for the cohort. It does have Docker running though. If I run sudo docker run hello-world, as you can see, it does say hello from Docker. So it does have Docker already installed. All I have to do is one, sudo docker pull this. Why sudo har kiya? Because the way that I installed it on this specific machine, it was not great. It does not have the right permissions, which is why I need to run it with super user permissions. Sudo docker pull the name of the repository. It will by default get it from DockerHub. Again, as I've mentioned before, you can push it to an AWS registry, a GCP registry. It's just currently on DockerHub, which is where we pull it from. After you've pulled it, all you have to do is run sudo docker sudo docker run and the name of the repository, which in our case is 100x devs test during video. If I run this, it says example app running on localhost :3000. The question is it now deployed on the internet? And the answer is yes. Let's go to the URL of this EC2 instance :3000, and I don't see anything. Can you tell me why? Take a break, think about it. Why does this not have anything running here, even though I've run the docker command? You guys are smart enough to figure it out. I'm going to stop this Docker container and rerun it with the, you guessed it, port mapping. Now if I press enter, with the right image name, if I go here, I see the website. So I can deploy it on the internet, your friend can deploy it on their machine, you can send this DockerHub link to anyone and it just works. Now you might be asking, Harkiya, this is not secure. I do agree, there are ways to like make your website secure, which like for example Google is or Twitter is. I go to Twitter, it says secure. I go to this Hello World website, it's not secure. There's like a whole different story for a different day. For now, you are able to create an image, deploy it on DockerHub, and you are able to pull it on an EC2 machine. So basically everything that's mentioned here is done. Let's proceed. These are the 5 commands that you should understand by now. Building an image, running a container. Docker login is one that I missed. So you can't just push to my repository. I just randomly ran like Docker push here and it just worked. The reason is before the video I did like a Docker login here. That is something you need to do after you have signed up to DockerHub. When you do a Docker login, it will ask you for like your username and password, just give it to it. And once you do, it has Docker CLI basically has access to your DockerHub, so it can push images there. As you can see, it says logging in with your password grants for better security, logging with limited privileges, and you can like create these things called access tokens somewhere here in DockerHub. And once you do, you basically like access tokens, you can restrict a specific access token to a specific repository. You can give like specific access to this Docker CLI. I've just given like complete access. Feel free to do that if you're like testing it out. When you're working actually in production, each repository has like an access token associated with it, and these deployments sort of happen via GitHub Actions, and that GitHub action only has like access to that access key. But like feel free to ignore all of this for now. Going back to the slides. So Docker build, Docker run, Docker login, Docker push, and Docker pull. These are the 5 commands that you should understand hopefully by now. And let's inspect one more thing, the build times really quickly. Okay, how much time did it take for the image to build? When I ran Docker build, if you might remember, it took almost like more than 60 seconds to do 1/4, which was pulling the image from DockerHub into my machine, right? There were a bunch of other steps after it. But if I ran Docker build again, as you saw, it did not take as much time. It only took like 5.7 seconds or 3 seconds because it already had the image locally, the Node.js 20 image. So it sort of understands and remembers it somehow. How we will see in the next video. But like one thing to know is like Docker is pretty smart in what's called caching, and it uses something called layers to cache. Again, it's something we will discuss in the next video, but I have to leave you guys with an assignment, which is why I wanted to discuss this. These build times sort of go down as you do recurrent builds. You do it the first time, it will take a really long time. Second time, it won't take as long. And as I said, there are like 4 things that are being built at the very high level. 1, you get like the Docker image, that's this 1/4 here. 2, the working directory. 3, copying over code base, and 4, running npm install. There is one small problem in the way we've sort of created the Docker file. I would make one small change. If this was like a production Docker file, I'm not going to share that change, but I'm just saying that's one small change that needs to be made here, which is something you need to figure out as the assignment. And I'll do something that will make Docker builds faster. What that is, I'm going to leave as an assignment, but I'll give you a hint as to what I'm expecting. Though there is a small problem in this Docker file. The problem is, if I ever change my index.js file, and this is my source code, if I ever change my index.js file, what will happen is this step will change. Copy ... now copies over something new. If I run Docker build once with a certain index.js file, all these commands run from the top to bottom. I change the index.js file, I run Docker build again. When Docker is building for the second time, it will see, oh, Node.js 20, it's the same as before. I have cached it, I'll proceed very quickly. Oh, workday /user/source/app. I have cached this, I will proceed very quickly. When it will reach this step is when it will be like, oh, sorry, initially index.js was different, now index.js is different, which means this step onwards, index.js will sort of change, which means if you look at these steps here, 1 by 4 will be the same. If I've only changed one file in my source code, 1 by 4 will be the same, which means the Node.js image still the same. 2.4 will be the same. 3.4 may not be the same because I am copying over a new JavaScript file, which means this will basically not be cached. As you can see, it says cached here. And again, npm install will not be cached. The reason for that is whenever you change, these are what's called layers in Docker, which is something we'll discuss in the next video. But at a high level, all of these are like layer 1, layer 2, layer 3, layer 4. This is how Docker builds one layer on top of another. And once you've created this layer, if you build on top of it, if any layer sort of changes from the build before, for example, if I did Docker build once, I would get like an image, a layer 1 here, a layer 2 here, a layer 3 here, a layer 4 here, and these are what you see here as well. You see 1 by 4, 2 by 4, 3 by 4, 4 by 4. If I run Docker build again without changing anything, Docker will be like, I already know this, I've done this once. It will just use these cached images. That is exactly what you see here when it says cached, cached, cached. When I ran Docker build a second time, it said, bro, layer 1 is cached, layer 2 is cached, layer 3 is cached, layer 4 is cached. But if I changed index.js file between two builds, what would happen is layer 3 would be different. It would no longer be cached. And the problem is, if layer 3 is not cached, anything beyond that is not cached because the file system has changed now. So it can't really, cache the fourth layer when the third layer is uncached. So everything from there is uncached. And this is a problem because npm install is a very sort of expensive step. This step right here is very expensive, takes a really long time. And you would ideally want npm install to be cached if the only file that has changed is index.js. If between two Docker builds, only index.js is the file that's changed, which means external dependencies did not change. Package.json, which contains your dependencies, does not change. Then you shouldn't really have to run npm install. So there should be some way to move npm install up somehow so that this step remains cached if the only file that the end user changed is index.js. The reason I'm leveraging so heavily on this is because when you're in a full stack application, package.json doesn't change very quickly. This specific file that you see here, you don't really add too many dependencies very quickly, which basically means this npm install step should be cached because as you change index.js or your full stack application, you don't change package.json too often. So there's no need for this to be uncached or basically this to break the image caching. So what if there was a way to move this up the chain somehow is what you need to figure out. That's all the hint I will give. We will discuss this in more detail in the next video. But at a high level, that's sort of assignment number 1. Okay. Every step in a Dockerfile is a layer. What does layer mean? It basically means this is how Docker sort of creates an image. When you tell Docker create an image, it will first create layer 1, which will be the first step, then it will create layer 2, the second step, third step, fourth step. The number of steps equal to the number of layers. If you ever change, let's say, the very thing at the very top, okay, bhai, I move from node 20 to node 19, what would happen? It would mean layer 1 changed, which would mean every layer after that also changed, which would mean, if I go back a slide, yeah, it should mean, okay, now everything is uncached, bro. You changed node from 20 to 19. This layer will re-pull a Node.js 19, which will take almost 2 minutes. This layer will also be non-cached now. Nothing is cached after that. After a layer loses its caching, every layer that comes after it is also no longer cached. It's being rebuilt from scratch. This makes sense if this is the thing that you're changing. But if the thing that you're changing is this thing, then layer 1 and layer 2 can still be cached. Only layer 3 and layer 4 are what need to be uncached and what need to rebuild. But as I mentioned, there is a way to optimize this a little bit by somehow moving npm install up the chain and a few files down the chain, which is something you need to figure out. That is the next assignment. What is assignment number 1? Figure out a way to make Docker builds faster if you know you are in a full stack application. And I tell you, okay, package.json does not change very heavily, and package.json is what governs how this specific command will run. If package.json changes, then the output of npm install changes. If package.json is same across two builds, then npm install can be the same, which means if somehow I could push this up the chain, and if only thing that is changing through a full stack application's life cycle is index.js file, somehow this can be pushed up the chain, we can like save some build time because we can somehow cache this. This is the step that you need to understand how to cache. That's all the hint I'll give. And second assignment is, this image is like pretty heavy. As you saw, like it was almost a 1 GB image. Figure out a way to find a more lightweight image and run Node.js application. And there is a way to run this specific Node.js application in just like 110 MBs. So figure out how you can do that, what you have to change exactly to be able to do that. Cool. These are the two assignments. Solutions are on GitHub already, but I'd urge you to not look at them right now. Cool. Quick recap of what we've learned. We've learned what is containerization, the history of Docker, how to install Docker on your local machine and play with it. What are containers, what are images, what is the difference between them, creating a simple full stack application and creating the Docker file for it, containerizing the backend, deploying the backend to DockerHub, pulling the DockerHub image to your AWS machine and starting it. A small flaw in our approach, which is assignment number 1, and again assignment number 2. Bonus is caching and layers in Docker, which we discussed a little bit. What are layers? We will discuss that more in the next video. The next video, we will start with what are layers and what is caching, volumes and networks, multi-stage builds, understanding what is Docker Compose, and adding a database to our backend. So some more backend code we'll write, and then creating a Docker Compose file for our project and going through some open source projects and making sure we understand everything there. Cool. Let me know how was the first part of this full stack, not full stack, 100x Devs YouTube Bootcamp. And as I said, it is this video, then it is next video, and then the coast is clear. Let me know what you guys want to learn next, and we're happy to do it. With that, let's end it. I'll see you guys in the next one. Bye bye.